Today I would like to give a presentation on synthesis of carbon quantum dots with narrow bandwidth red fluorescence. Carbon quantum dots are fluorescent carbon nanoparticles. They have achieved great attention due to their advantages such as low toxicity, high biocompatibility, high photostability, eco-friendliness, and facile preparation. These advantages allow them to be alternatives to quantum dots that contain toxic elements. Conventional CQDs show strong fluorescence in the range of blue to green and broad emission peak compared to quantum dots. When fluoroglycinol is heated at 180 degrees for 6 hours, a dehydration reaction proceeds between adjacent molecules to produce CQDs with narrow bandwidth fluorescence. This is attributed to the uniform electron donating functional groups and rigid triangular structure. The purpose of this work is to achieve narrow bandwidth red fluorescence. PG-related carbon source, DAR, were used to prepare DRCQDs. The effects of amino groups on optical properties were investigated by theoretical calculations. The average particle sizes of PGCQDs and DRCQDs were 1.7 nanometers and 2.2 nanometers respectively. The lattice fringe corresponding to 100 lattice spacing of graphene were observed in both CQDs. PGCQDs and DRCQDs dispersion in ethanol displayed blue and red emission respectively under 365 nanometers UV light. The emission spectra show a sharp emission peak with a bandwidth of 0.16 and 0.14 electron volt respectively. The respective relative photoluminescence quantum yield was 64% and 31%. The nitrogen 1s XPS spectrum of DRCQDs was composed of two peaks corresponding to NH and NH2. The peak area ratio indicates that most of the nitrogen were introduced as NH2. The Raman spectra showed two peaks of D-band and G-band. The intensity ratio of G-band to D-band of DRCQDs were smaller than that of PGCQDs, indicating that more defects were formed in the graphene structure of DRCQDs. The optical absorption spectrum of dehydrated condensed molecules of PG and DAR were calculated based on the density functional theory. The calculated absorption peak corresponding to the HOMO-LUMO transition shifted to lower energy when amino groups were introduced in the structure. In conclusions, DRCQDs were synthesized from a PG-related carbon source, DAR. DARCQDs showed red fluorescence and narrow bandwidth of 0.14 electron volt, which is comparable to quantum dots. The low energy shift of the emission peak can be attributed to the quantum size effect in the introduced amino groups. The lower quantum yield of DRCQDs may be due to the defects in the graphene structure formed by the dehydrogenation of amino. Thank you for listening.